Develop a procedure to prove complexation of PEO with salt using FTIR. FTIR is a non-destructive analytical technique used to identify and analyze chemical compounds. FTIR measured a sample's infrared absorbance or transmittance at various wavelengths to determine the functional group and chemical bonds present in the sample. Recently, attention has been focused on the study of polyethylene oxide, PEO, based polymer electrolytes complexed with lithium and sodium salts, because of their direct application in high-energy density rechargeable batteries. Complexation is the combination of individual atom groups, ions, or molecules to create one large ion or molecule. Examples of factors that affect the degree of complexation are ionic strength, temperature, pH and competing ions. 2 steps are required to demonstrate PEO complexation with salt using FTIR, such as sample preparation and FTIR analysis. In sample preparation, PEO complexed with sodium trifluoromethane sulfonate, NaCl3SO3. There were 6 steps in the sample preparation. First, PEO complex is prepared by solution cast technique. Second, 1 gram of PEO is dissolved in 40 milliliters of acetonitrile solution, and the mixture is stirred until the PEO powder is completely dissolved. Next, 14 to 22 Wt% of sodium trifluoromethane sulfonate is then added into the solution, and stirred continuously until a homogeneous solution is obtained. Fourth, the solution is then poured into glass petri dishes, and then left to dry at room temperature. Finally, the thin films produced is used to undergo FTIR analysis. FTIR spectra is a plot of measured infrared absorbance or transmittance intensity versus wavelength of light. Typical absorbance bands are grouped into 2 regions, which are functional group region and fingerprint region, as shown in the figure. The common observation to confirm the complexation of polymer hosts with the salts includes changes in the intensity of peaks, shifting of the peaks with respect to the salt concentration, appearance of new peaks and broadening of the bands. In this case, the pristine PEO will show peak at 2,876 cm power of -1 ch stretching, 1,465 cm power of -1, ch2 scissoring, 1,087 cm power of -1, co stretching, 971 cm power of -1, ch2 twisting, and 836 cm power of -1 ch2 wagging. The addition of NaCl3SO3 to PEO results in new peak bands at 760 cm space power of -1 and 638 cm power of -1. The band that appears at 630 cm power of -1 in pure NaCl3SO has shifted to 638 cm power of -1 when NaCl3SO3 added to PEO. Besides, a band that appeared at 1036 cm power of -1 in pure NaCl3SO3, due to triflate, SO3, symmetric stretching decreased to 1030 cm power of -1 when increasing salt concentration. At higher salt concentration, most of the band in this region is also slightly broadened. Moreover, the width of CO and CH stretching band at 1087 cm power of -1 and 2876 cm power of -1 respectively decreases when salt are added compared to pure PEO. The presence of new bands and change in shape, position and intensity of the peaks confirms the complexation of PEO and NaCl3SO3. There were references that were used. That's all for the presentation. Thank you.